All right, folks, we're going to pick back up where we left off. We're taking a look at these myofibrils. So what we want to take a look at now is we just want to continue on and take a look at what these things are actually doing. It says the light band is also called the I band and has a dark midline interruption called the Z disc. So this is our I band right here. Notice this Z disc, this is where our actin filaments are going to hook up to. So we've got all of our little actin filaments hanging out right here in the middle, and they're all going to attach to this Z disc. And this is a lighter area because you don't have myosin filaments in this area as well. It only has actin filaments. Our myosin filaments stay way over here, so therefore this is going to provide a lighter area. So this is called the I band, also known as the light area or the light band. It says the Z disc marks the end of the sarcomere. So this Z disc right here is where a sarcomere is going to begin and end. So one section from Z disc to Z disc is called a sarcomere. The dark band is also called the A band. So this is our A band right here. Notice I have myosin filaments and I have actin filaments in this area. So the presence of both of those proteins, the presence of both of those filaments is what causes this area to be darker. The H zone is right here in this area, and the H zone is going to be slightly lighter because it doesn't have actin and myosin filaments. Okay, notice it just has the myosin filaments in this area. Okay, now that's only while it is not contracted, and we'll take a look at that when you talk with Miss Johnson here in a little while. But this area is during a relaxed time period. This is a lighter area as well because it lacks actin filaments. You only have the myosin in this H zone. Says notice that the I bands and the A bands are responsible for the striations of skeletal muscle tissue. So we know that skeletal muscle is striated. That's something that we learned in the tissue unit, and that's something that we're going to talk about again here. Skeletal muscle is striated, and the reason for that is because of these dark bands and these light bands. So the whole idea behind striations comes from the fact that we have thin filaments or actin filaments as well as these thick myosin filaments. That's what gives us our striated look to our muscles. So if we take a closer look at a sarcomere, notice here, we know that this is a sarcomere because we go from Z disc to Z disc. These thin filaments are called our actin filaments. These thicker filaments are called our myosin filaments. It says the bands of myofilaments are actually formed by many myofilaments packed together. So these are going to be just packed in here, and that's what gives us that look of having the bands, is you've got all of these that are packed into this area. Notice all of our actin filaments attached to the Z disc. So our thick filaments, these big thick red filaments here, are myosin filaments. Okay, they're going to contain our myosin protein. They're also going to contain ATPase, which is an enzyme that helps split ATP so that we can actually generate power for the muscle contraction itself. Our myosin filaments are going to be responsible for